Hi guys, BuildZoid here, and more filler. 3060s came out, so we're gonna take a look at some of them. Thanks to Tech Power Up, we're just gonna look at the ones on Tech Power Up. We're gonna talk a little bit about 3060s. Anyway, I feel really bad when I use Tech Power Up's website like this. Like, already I credit them when I do the PCB breakdowns. Um, but yeah, like, I don't feel like doing PCB breakdowns for the various 3060s. I don't really find them that interesting. But, people might be interested in 3060s, so here we are. So let's get into it. Starting off with actually, no, the first thing I want to talk about, I guess, is the whole 12 gigs of VRAM versus, like, like you've got your 3060, it's got your 12 gigs of VRAM on the 192-bit bus, and then if you look at, like, a 3060 Ti, that's 8 gigs. Or the 3080 is 10 gigs, right? And a lot of people go like, why does the 3060 have so much VRAM? Well, it's very simple. If you have a 192-bit memory controller, you can have 3 gigs, you can have 6 gigs. Actually, I'm not sure you can even have 3 gigs. GDDR6. Can't. Why? Why is it always crappy news articles? Anyway, so actually, yeah. So so there's there's two valid memory configurations for a 3060. You can either have it with 6 gigs of VRAM or 12 gigs of VRAM. You can't really have anything else in between. Not without ending up in a really awkward memory controller situation. So that's why it's a 12 gig card. Because also it would be super awkward even from like a manufacturing perspective, because theoretically you could build like an 8 gig 3060, and the way that would work is you'd have your 6 chips on the front, and each of those is 8 gig. So these are 16 gigabit memory chips, right? Pretty sure Tech Power Up. Yeah. Wait. Well, we can actually just look these up, I think. Indeed, we can. And these should be 16 gigabit. Yeah, so these are 16 gigabit memory chips. So each of those memory chips is 2 gigs of VRAM. So instead of these 16 gigabit memory chips, you could use 8 gigabit memory chips, which are 1 gig of VRAM each. So you'd have 6 memory chips on the front of the card, each of them being 1 gigabyte. You'd get 6 gigabytes of memory on the front of the card. And then what you would do is you would put 2 memory chips on the back of the card in clamshell mode. And the reason why you wouldn't do that is like, yeah, that would give you 8 gigs of VRAM, but the memory, the way the memory system would end up working is you would have 6 gigs of VRAM accessible at 192 bits per second, and then you'd have two more gigs. You wouldn't have 8 gigs accessible at 192 bits, at 192-bit bus width. You'd have 6 gigs at 192, and then you'd have 2 gigs at like 32. Which is really dumb, right? Like, that is incredibly dumb. So you wouldn't do that. I think there's some other sort of weird configurations that you might be able to do, like 2 gigabyte chips, and then 4, you could also do like 2 gigabyte chips, and then 4 1 gigabyte chips. And in that scenario, you'd have 192-bit access to 6 gigs, because you'll still have access to 6 gigs, and then you'll have 64-bit access to 4 gigs, I think, or 2. No, it would still be 2. Anyway, so basically your memory controller wouldn't have a consistent memory bandwidth, and that's really like basically what would happen is the performance would, depending on how the game is using the VRAM, what could end up happening is, like, let's say the game loads up 7 gigabytes of assets, and there's an asset that it uses very, very regularly at very high memory bandwidth that, spilled over into the 1 or 2 gigs of slow VRAM that you have because you have this awkward asymmetrical memory setup. Well, now the game chugs because every time you need to access that stuff, you're accessing it at like a fraction of the speed of the entire memory of the first 6 gigs. So There have been cards in the past where NVIDIA would have these asymmetrical memory controllers. The most extreme example would be the GTX 970. That had the whole 3.5 gig controversy around it. So, yeah, if NVIDIA didn't want to have some weird, like, 6 gig controversy with this, it was 6 gigs or 12 gigs. And 6 gigs is arguably too little VRAM for a card at this price tag. And 12 gigs is too much, but they didn't have a choice. There's like, what else were they supposed to do? Because the card physically is not compatible with 8 gigs of VRAM, and you might be looking at like those unpopulated memory chips and going like, but unpopulated memory chips, does this not have a 256-bit memory controller? And what is this? This is the GA. Yeah, this is a GA106. And actually, we can use the database because yeah, there's no configuration. So as far as I'm aware, this is a 192-bit core. So like, yeah, that's that. Like the silicon does not physically have 256 bits of memory controller, so you can't have 8 memory chips connected to it in any symmetrical configuration. You could have an asymmetrical one. We already talked about that. But anyway, so yeah, you could NVIDIA was stuck with this, but you might be looking at the PCB going like, wait a minute, it's 2 unpopulated memory chips. Well, the thing is, I believe NVIDIA, what they did. Actually, we can just use a 3060 for this. I believe what's going on with that is that NVIDIA is actually using the substrate is similar for both. So like if you have, it's kind of like putting kind of like how you have the 7740X CPU, right? Which is a dual channel CPU that goes into the LGA 2066 socket, and that the LGA 2066 socket is for like quad channel Skylake X CPUs, right? So similarly, you can have a substrate with a BGA that's configured for 256 bits, but you can also use that same size substrate with basically the same pin configuration for a chip that only has 192 bits. Which this is a cost optimization thing because substrates, I would assume, are cheaper than PCB assemblies, and so it's much more convenient if you can, whack 3060 cores onto 3070 PCBs, right? Like this is actually a 3070 PCB. Like, yeah, this is a 3060 Ti, but if we keep scrolling, where's the 3070? Like, it's a 3070 PCB. See? It's the same thing. Or it's the same PCB every single time. And that's a cost optimization thing because you don't need to design a new PCB for the chip by just using the same BGA pinout. So yeah, there. So that's why you have the 2 unpopulated memory chips. It's kind of like if you put a 7740X into a X299 motherboard, there's still, however many DIMM slots on the board. That doesn't mean that they're going to do anything if you put memory sticks in them, right? So these pads basically lead to nothing as far as I would assume like the connections for the memory chips over here, they just don't go anywhere. They might they'll still go up to the substrate, but they won't go anywhere in the substrate. Like the substrate will just be the dead end. So yeah, so that's what I assume is going on. I don't know for sure that that's going on. Like this might actually be a 256-bit core, and NVIDIA just doesn't want to enable the full controller for performance reasons. But I'm leaning towards towards it being a 192-bit core that they put onto a 256-bit substrate, which the chips don't have anything to connect to. So anyway, Yeah, that's kind of that. In terms of the PCBs, well, MSI is not doing anything particularly impressive here. We've got a 7-phase V-core, which is kind of an odd phase count, but totally viable. Like, if the controller goes up to 8 phases, it can support... Well, I'm not sure. There might have been some controllers in the past where you couldn't run, like, odd phase counts or something, but generally speaking, if the controller goes up to 8 phases, it can run 7, it can run 5, 3, whatever you want. Anyway, NVIDIA MSI is using the NCP81610, which is roughly on par with the UP9512. It might be slightly better, but I've not gone and dug through the datasheet that much. It goes up to 1.2 megahertz switching frequency. So yeah, not a bad controller. PWM vid, which is standard for NVIDIA GPUs, has an I2C interface. I think it's more digital than the 9512. Like, this should be more configurable than the 9512 is, but again, I've not really paid that. Like, I didn't go through all the different, like, I didn't go through the register map for the 81610 and then the 9512 and go like, oh yeah, there's these extra registers on the 81610 that the 9512 doesn't have. Like, I've not done that. This does look, however, like it has a more complete feature set than the 9512 in terms of digital controls. Anyway, yeah, so that's the controller used, and MSI is using onsemi 30, 20, 45 DR MOS components. These are 45 amps, so not particularly amazing. I have no idea what the hell this thing is. I thought it might be an on semiconductor part because there's like the NCP. What's it called? 5320. Yeah, there's the 5320, but no, this is not related to the 5320 at all. I have no idea who makes this. So that's fun. It might be actually, I don't know that Nyko Semiconductor makes controllers. But anyway, the MOSFETs are from Nyko Semiconductor for the memory VRM. Nyko Semiconductor makes terrible MOSFETs, but luckily you don't need good MOSFETs for powering a couple gigs of GDDR6. So yeah, that's like if these were anywhere, if these were in any high power rail, then I'd have a problem with it. But here, that's fine. Like, it's just GDDR6. It doesn't pull that much power. It's also not a lot of GDDR6, right? Like, it's just 6 chips. So yeah, this is fine, and it's a 2-phase. But yeah, these aren't very good MOSFETs at all. That's a 616 and a what looks like 698. The 616 is awful. MSI used to put these on a lot of, like, not even really, well, low-end motherboards. Yeah, they'd put these on, like, if you put a 616 in your V-core of your motherboard, it doesn't matter what the price tag is, it is now a low-end motherboard. Because these are that bad. But yeah, so low-end MSI motherboards would regularly use the 616 as a high-side MOSFET, and it's terrible MOSFET, but that's why it was in low-end motherboards. Like a lot of AM3 Plus motherboards using those MOSFETs would die. Partially because, FX8 cores pull a lot of power, partially because those MOSFETs bloody suck. So anyway, well, yeah, for a GPU for powering the VRAM, that's fine. Also, MSI does have some input protection fuses, which is, like, it doesn't really do anything for you if you don't like it makes the repair job for somebody who's actually capable of repairing the PCB a lot easier than if the fuses weren't there. But yeah, they don't really like it doesn't make the card easier to repair unless you already know how to do PCB repair. It doesn't really protect it won't stop the card from dying. It minimizes how much damage occurs when the card up and dies, basically, is what that's for. And yeah, so this is a 7-phase using 45 amp power stages. What I do find kind of interesting is that MSI did opt for some extra multi-layer ceramics behind the GPU core, and it's also nice that they're using the 3070 PCB instead of using a cheaper PCB. I think the 3070 PCB has a higher layer count than which should lead to some slight benefits, but it's hard to confirm GPU PCB layer counts. Like, the only reason you can tell layer counts on some motherboards is because they have a layer count indicator. GPUs generally don't. Anyway, yeah, but interesting capacitor configuration behind the core. I'm surprised that they bothered to populate this. I guess they set up the card and then they decide whether to turn it into a 30. No, because the VRM configuration is different. So yeah, I'm not sure how that happens. Like, why are these capacitors over there? I have no idea. There's no memory chips on the other side, so these shouldn't, like, these aren't necessary. So yeah, I'm really confused. Like, they even have a bunch of like configuration resistors in there. I guess they just didn't want to change the programming on the pick and place machine or something. Well, these are through hole components, so though, but you're like missing phase components. So yeah, this is just completely random that this is here, but yeah, that's there. It doesn't hurt anything by being there. I'm just surprised that they've left those on there. On the other hand, they've not included any of the extra bulk caps for the memory. Not on the back and not on the front, which there is a card that there is a 3060 that does include those, which I'm a big fan of. So anyway, that's the MSI 3060. Then we've got the Zotac 3060, and this is the one I'm a big fan of. And I'm not normally a fan of Zotac cards, and, you know, like, honestly, they're not doing anything particularly incredible here, but the thing is, they just took a 3070 reference PCB and then fully populated it. So what we've got here is a 1, 2, 3, 4, 5, 6, 7, 8, 9... Wait, what? I can't count. 4, 9, 10. Oh, yeah, it's a 10. Yeah, it's not a 9 phase, it's a 10, because that inductor over there is connected to this power stage over here, and that, if you look at the back of the card, where's that inductor? That's this inductor over here, which then you can sort of see the power plane is actually part of the V-core. So that's really whack. But yeah, this is a reference 3070 PCB with some slight adjustments. There are it's not completely referenced, but yeah, slight adjustments. Zotac did include some extra capacitors for the memory chips, which might lead to slightly better memory overclocking. They've also seemingly loaded out the back of the core. Like, this is full. I'm not seeing any blank pads, so that's neat. 470 SP caps behind I'm guessing those are SP caps. 470 microfarad capacitors, so I believe the minimum specification is 220, but yeah, 470 should be helpful. 3070 PCB, which again might be an advantage. UP9512 controller for V-core. That's an 8-phase controller, so the whole 10 power stage thing is, again, it's running weird. NVIDIA V-core VRM things, I still don't know how they do that. Anyway, memory is controlled by a UP1666, so very easy to volt mod the memory control. There's a US5650 for current monitoring down here. And this uses BLN0 alpha and omega power stages, so those are 50 amp parts, so that's nice. So yeah, like this is a very substantial VRM for a 3060. Which is why I'm a fan of this. Then for the memory power, we've got these Sinopower 7340s. Actually, let's look these up. Man, I can't type. 7340. Oh, there we go. Channel 1. Actually, that's not bad. That's really good, actually. Like, damn, that's low. That is really, really low. 7340EH. Damn. Those are some sick dual NFETs they got there. I'm surprised. So even the memory VRM on this is that's that is really low for a high side. So yeah, damn, that's a solid memory VRM they got, and you know, and then they have the extra bulk capacitors. Like, I like this more and more. So yeah, I think the only complaint, like, if you wanted to do like extreme overclocking on a 3060 for some reason, this certainly has the best VRM loadout. The only issue is that inductor, that capacitor, this inductor. Probably going to be a problem. These capacitors, that inductor, those fan headers, there's a lot of stuff that gets in the way if you wanted to attach an LN2 pot. Though I guess you could use a riser and like flip the card upside, like put the card, like use a CPU pot then and have the card sitting down, and then you don't have to worry about like the component clearances. But yeah, so for LN2 overclocking, the PCB is a bit awkward in terms of the component layout, but nice components. Like, really nice components. I'm really surprised by those dual NFETs. I was expecting, like, 7 milliohms RDS on for the high side and, like, uh, 4 for the low side. And instead we're getting, like, less than half that. Like, way below half that. Like, 0.75 and 2.5 milliohms at 10 volts gate to source voltage. Like that is, they might be running them at 5 volts, but even then, like 4.2 milliohms on the high side it's low. That's a really low resistance high side, and that's great for efficiency. And then the same for the low side, like 1.2 milliohms. That's great. So yeah, these are some really nice dual NFETs that they're using, which I'm really surprised by because normally like Zotac, Zotac to me isn't the company where I expect to see like good MOSFETs. Lots of MOSFETs, yes. Good ones, not necessarily. But yeah, we've both got a lot of power stages and good power stages, so I like this. But I guess it's kind of easy when you just take the 3070 PCB and then fully populate it, and then just instead of putting a 3070 core on it, you put a 3060 core. Bam. Who would have thought that the PCB meant for a significantly more powerful card works is so good for a less powerful card? Um, anyway, now we move on to EVGA and Palit. So EVGA is not using a reference PCB in the sense that no, this is not the page I wanted to go to. In the sense that there's this airflow restrictor right here. Yeah, and then Palit isn't doing that. I think Palit is actually using the full-blown reference PCB because this thing just ends. And this is really cool. Like, this thing is small. Like, this thing's barely long. This is actually shorter than the PCIe slot. Like, if you consider where the clip on the PCIe slot is, like, yeah, you know, the non moving parts of the PCIe slot, yeah, they end right there. But like, the clip is actually long, like past this card. So like, damn, this thing is short. Anyway, so yeah, this thing just ends, whereas EVGA is like, hey, you know what's great for airflow? PCB. And yeah, so they added all of this over here for some reason. We've got what? Both of these use a 5-phase VRM. Both of them use, I believe, the 9512. Yep, that's a 9512. And this is on a 9512 because, of course, it is. I guess we'll find out if the... Oh, I guess maybe the 470 microfarad caps are the minimum specification. But you'll notice some of the multi-layer ceramics are missing compared to the Zotac card. Yeah. So some of the multi-layer ceramics are missing compared to the Zotac card. And then, of course, MSI was using some multi-layer ceramics just in place of one of the SMD polymers. So that's an interesting difference. Is EVGA? Yeah, EVGA is also, yeah. So I believe this is like the actual reference spec, and neither of them is populating the unpopulated memory chips, which I believe this is the actual 3060P. Like, this is a 3060 PCB, and I also think it has a lower layer count because you can see all of the display output traces running through. I assume they're display output traces running through this area. Whereas if you look at the Zotac card, like, this is a power plane. And it's like, well, there's still display outputs in the same location, so it's like, where are the display output traces? Well, they're probably like somewhere on a different layer that we can't see because this probably has like 2 layers more than this does, is my guess. Again, I'm not 100% certain. The PCBs don't have layer count indicators, and it's not like somebody's cut one open to count the layers. So, you know, but yeah, just the fact that like this is a straight up 3070 PCB, and this isn't. Like, I don't remember seeing a single 3070 that looked like this. I'm going to go with this probably has less layers, which is why we can see all the traces running through it. Anyway, memory controller is a 1666, so yeah, that's the standard. Super easy to volt mod chip. There should be public documentation for it. Ubic. And we're gonna get a warrant. Oh yeah, not secure. Yep, see? Bam. Everything you need right here. And basically the pin 7, whatever voltage is set on pin 7 is the voltage you get at the output. So if you want to volt mod this, you just have to take over pin 7. They even give you a lovely schematic to tell, like, to show you what kind, like, and this is actually what the circuit looks like on the cards. So yeah, and there's, like, I believe almost full documentation. Yep. It doesn't even say confidential, does it? Good. I don't have to feel bad about showing it. Because sometimes Ubic's website is a bit funny. Sometimes they have data sheets on their website that I don't think you should have access to. Like, you'll open up the data sheet from their website and it'll just have, like, UPI semiconductor confidential just plastered all over it. And it's just like, yeah, but I literally got here through, well, not through Google. For whatever reason, Google has a really hard time finding the Ubic semiconductor website. But unless you, like, specifically look for it. Like, if you punch in the various UPI part numbers, it doesn't very reliably pick up the data sheets. But yeah, if you just go straight to UPI, then it's like, data sheets up here. Like, who, like, if it's not supposed to be public, why did you upload it to your website? And link it on the freaking, like, chip, like the page for the controller. Anyway, yeah, so that's a super easy to volt mod controller. And that's also true of the 9512, though. Is the 9512 public? Because that's the one that disappeared for a little bit. Yeah, no, it looks like that's public too. Bam. Same circuit for the voltage control here. And oh, I guess they're not doing the UPI confidential thing anymore. Because I'm pretty sure I have a copy of this data sheet from, like, when the 20 series came out that has UPI confidential going over it. Anyway, so yeah, so these are the weakest. These do still use 50 amp power stages though. So it's not like, so the power stages here, there's a lot less power stages, but they are stronger than the ones that you would find on, say, the MSI card, but not enough to offset the fact that this is a 5-phase, the MSI is a 7, and then the Zotac card is a full-blown 10 power stage. It's not a 10-phase because the controller doesn't go that high. And I'm still not sure, like, I'd love to get a chance to measure one of these awkward, like, power stage count NVIDIA cards. Like, just hook up an oscilloscope and measure all of them. Oh, and we've even got Ubic Semiconductor dual NFETs. I don't know what these are, and these are, actually, we can try look them up. 3828, 3828, wait, no. Yeah, that doesn't generally work. For whatever reason, getting dual NFETs from them is real, like, for some of their MOSFETs, getting data sheets is really hard. Like, 3054, that one I think, oh, that one's also gone? QM. Do they just, like, I guess those are discontinued, so they're not on the website anymore. Oh, that sucks. QM 32? Is that a thing? No. Oh, this one for, like, ages and ages and ages, I couldn't get a data sheet for it, and now it's finally public. Oh, well, it's public as of last year, end of last year. And this MOSFET has been used on cards since, I believe, the 10 series. So that's annoying. You know, it's just like, yeah, so we've been, you know, shipping cards with this. Oh, yeah, so, yeah, that's a more normal high side, low side configuration compared to this thing. This is really low for a high side. This is more like the kind of thing I'd expect to see. You know, and actually this honestly is kind of terrible compared to the SM, like, yeah, it's honestly kind of terrible compared to the Sino power MOSFETs. Anyway, it'll be fine, like, it's GDDR6. Like, it's a couple chips of GDDR6, it's not going to run that hot. But yeah, so if for some reason, like, the thing is, you can't buy these things, so I don't really see the point of doing these PCB breakdowns when it's like, well, none of these cards are in stock. So are you really going to wait for stock of the, like, best PCB to come in? Maybe, I don't know. You might get lucky and like because this is going to be probably like more expensive than your like default spec 30. Well, actually all of them are super expensive now. So yeah, that's not going to work. Interesting thing of note, as usual, Zotac is using 1200 microfarad capacitors. Don't know who makes them or what lifespan they're rated for, but 1200 microfarads is a lot of like that's a lot of capacitance because normally, okay, that's the same thing. Um, Normally you'd see like 820 microfarad caps. Which I don't think the extra capacitance really gives the Zotac card any advantage. The through-hole capacitors just really aren't that like amazing in terms of dealing with the high frequency transients that a GPU core creates. So of the cards uploaded to Tech Power Up, the PCB quality sort of order is Zotac first, to my great surprise, then MSI. So actually Zotac first, MSI, then Palit and EVGA. Yeah, so Palit and EVGA are equal because like they're literally equal, right? Like, this only has 5 bulk capacitors. This also only has 5 bulk capacitors. That's interesting. And then there's the Zotac card. But the thing is, like, they're literally just using a 3070 PCB. So this is designed, like, that VRM is designed to handle significantly more power draw. And then if you want any more information on these cards, I recommend that you check out Tech Power Up's review of them because, yeah, they include all kinds of very interesting information that we're not going to go through because, you know, I feel like it's bad enough that I'm ripping off, like, using their images like this. So, yeah, if you want to know the rest of the stuff about these cards, you should go check out the reviews up on Tech Power Up. I'll leave a link to the I guess all of them. There's only 4 of them, so I'll just leave links to all of the 3060 reviews down in the description. And yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, comments or questions down in the comment section below. Don't leave suggestions. Almost said it, but don't. I don't care. I don't care for them. I have enough stuff to do as is. I don't need suggestions. And where was I going with this? Right, if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. There's a link to that down in the description below as well. Both the Teespring and the Patreon help out immensely with running the channel, so it would be much appreciated if you would check them out. And yeah, that's it for the video. Thanks for watching, and goodbye.